Napkin problem 4. Today, as you're preparing your organic high mountain Taiwanese oolong in the kitchenette, one of your lovely coworkers mentioned that they were looking at adding more radices because it was maxing out at 10,000 commands per second, which they were trending aggressively towards. You asked them how they were using it. Were they running some obscure order and command? They would BPF probes to determine that it was all get key and set key value. They also confirmed all the values were about or less than 64 bytes. For those unfamiliar with Redis, it's a single-threaded in-memory key value store written in C. Unfazed after this encounter, you walk to the window. You look out and sip your high mountain Taiwanese oolong. As you stare at yet another condominium building being built, it hits you. 10,000 commands per second. 10,000. Isn't that abysmally low? Shouldn't something that's fundamentally just doing random memory reads and writes over an established TCP session be able to do more? Hello there. Vector Podcast is back, season 4, and we are kicking off with an exciting topic. And the guest is Simon Eskildsen, CEO of Turbopuffer. I've been watching you guys from, almost from the start, just following each other on Twitter, like virtual friends. And it's funny that before this episode, you're the CEO of the company, and before this episode, you tried to sell Turbopuffer to me and said, "Hey, why don't you use it?"
And
Did you
Dimitri,
become?
Tom should puff.
It
Yeah.
should puff for sure. Uh, but tell me, hey, welcome. First of all, welcome, and thank you very much
Thank
for
you for
recording
having
with
me.
me. Yeah. Um, it's a tradition to usually start with the background. If you could speak in your own words about yourself, your journey. I know that you worked at Shopify at some point, also scaling databases, I guess, right? But I've also been following your Napkin math, newsletter. I was reading. Maybe I'll quote some text today from there, just to amuse and excite our audience. But tell me about yourself.
Yeah, I can give a very brief overview, and if we can dig into anything, if there's anything that stands out. I started programming when I was a teenager. Similar to you, English is not my first language, so at some point I exhausted the Danish web, and then like divulged into video game addiction for 3 years as a teenager to learn enough English to sort of, get my own ChatGPT moment and take off point. And then I spent a lot of time in high school being not very good at competitive programming, but good enough to qualify for the small country of Denmark. And then I spent almost a decade working at Shopify doing mainly infrastructure work. So when I joined Shopify and the infrastructure team, we were doing, I mean, it was not even an infrastructure team, like DevOps was just becoming a thing. And we were driving just a couple hundred requests per second. And by the time I left, we saw peaks of more than 1 million. And I more or less worked on all of the stateful systems that power that because they generally tend to be the bottleneck, just playing whack-a-mole every single year for every Black Friday for many years. And I spent the majority of those years on one of the last resort pagers for Shopify as well. One of those pagers where the pages are very scary in the middle of the night. And where a lot of GMV, of course, runs through Shopify. So very high responsibility on that. Um, I left in 2021 and kind of jumped around at my friends' companies, helping them with various things. And I'd spent almost my entire career at one company. So I wanted to dabble and just, go and basically help my friends with any infrastructure challenges that they had. And in 2023, when ChatGPT launched and the APIs launched, I was working with my friends at this company called Readwise. They have a product similar to Pocket and others for reading articles later. Phenomenal product. And they asked me to build a recommendation feature for articles, and it's like, well, that's perfect, right? LLMs or embedding models are basically just LLMs with their heads chopped off, and they're trained on exactly this data. So we built something, and it actually worked pretty well for just recommending articles. But then I ran the back of the envelope math on what it would cost to do this for the entire article catalog, right? With hundreds of millions of articles. And it would have cost more than 30 grand a month to do. And for a large company, that's not a big deal for an experiment. But this was a company that was spending 3 grand a month on a Postgres instance that prior to working on this, I tuned, and spending 10 times that on just recommendations and possibly search was just untenable. So it sort of it was lost in its track. And it was a bit sad. And it sort of ended up in that bucket that a lot of companies have of like, okay, we're going to work on this when it becomes cheaper and then we'll ship this feature. But it was a bit sad because I was excited
Hmm.
about this feature as a user of the product as well. And I could not stop thinking about that. Why was it so expensive? And the vector databases at the time were storing everything in memory. And DRAM on the cloud cost somewhere between $2 to $5 per gigabyte.
Hmm.
And this just the economics of this didn't line up. It wasn't that this vector database was doing anything, you know, malicious in their pricing. They're just trying to earn an honest margin on memory pricing, but memory pricing was just too high and it stopped this feature in its tracks. And what I couldn't stop thinking about is why can't we do all of this on top of object storage, right? Like we just put it all on object storage. That's the source of truth. And then when we actually need some piece of data, we put it in memory or even on disk if we can. And I did the math and math on that. And I was like, I think that's about 100 times cheaper.
Hmm.
And of course, that would have been a no-brainer for Readwise. We would have just bought it and started using it and tried it out, right? And maybe put way more data in and maybe worked our way up to that 30 grand a month bill, but with a different workload. And so, yeah, I couldn't stop thinking about it. And then eventually started writing the first version over the summer of 2023, just me alone in the woods of Canada, and then launched it in October of 2023, which is probably where you saw it. I didn't really tell anyone about it. I was just hacking away. Launched it, did a lot of R&D over that summer, insights that some of them still are in the product and a lot of them we've since phased out. But the most important thing was that it launched.
Yeah.
And the first version of Turbopuffer didn't have, I was just looking at the website the other day for an unrelated reason, didn't have mutable indexes. So you just wrote to it and then you called
Yeah.
an index endpoint and then you're logged in. Like that's it. And it didn't have any SDKs. It was just a big, you know, pure HTML website. But it was enough to ship it. And it caught the attention at the time of the Cursor team back in 2023. And of course, this was early on for Cursor. It was early on for us, and their vector database build did not line up with their per user economics and how they wanted to use RAG in Cursor. And so they wanted to try to work together. And we exchanged a bunch of emails of bullet points. And it was very clear that they thought that this architecture was exactly now, knowing the team now, they would have just sat down at the dining table, done the napkin math over there, and then thought, why hasn't anyone built it like this?
Hmm.
And so I went to San Francisco and spent some time with them and came up with a bunch of features that they would need and called the best engineer that I knew at Shopify, my co-founder Justin, and asked if they'd come on board because I think maybe there's something here.
Hmm.
And yeah, we launched it. Cursor moved over, and their bill was reduced by 95%. And
Wow.
of course,
Huge.
the traditional storage architecture they were on before didn't make sense for the Cursor economics, but our storage architecture really did because you put all the code base embeddings on S3, and then the ones that are actively being used, we can use in RAM or have in disk.
Hmm.
I'll stop there, but that would be what led up to this moment.
Oh, that's amazing journey. A lot to ask, of course, a lot of questions, but just on that cursor thing, as I told you before we started recording, I knew about you launching this, working on this, and then I've listened to the Lex Friedman podcast episode with the cursor team, and they did mention Turbopuffer, sort of like in passing, but I think that also probably created a lot of attention to you guys. But I'm just curious, like, how did you get together? How did you know Cursor team somehow? Someone on the Cursor team that you could like partner early on and essentially help, they kind of like helped you to pioneer it, right? In some sense, becoming the first client or maybe future client, right? How did you approach them.
They did. I mean, they were a design partner in every sense of the word, right? We had a Slack channel, and I feel like they treated us as part of their team, and we treated them as part of our team. They came inbound. They sent an email based on the website, and they said, "Hey, we would need mutable indexes and glob and a couple of other things." So it's like, well, those are very reasonable requests, right? And I think they had the conviction that that this was the right architecture, and like if we could prove in their trust, then we would be in a good place. So it was really just it was just an honest conversation, just the way that the website is today, a very honest description of what are the trade-offs, what can it do, what can it not do, what is the latency profile, what are the guarantees, and that's exactly the kind of bullet point discussion that we engaged in over email before I met the team in person. Yeah,
Awesome.
and they of course they were a small team at the time, right? It was a and they needed help with with parts of their infrastructure and working very closely with teams that they could trust with the right economics and the right reliability.
Yeah, for sure. But I guess that honesty, which I also value a lot, and in my work as I became a product manager, 3 years ago, and I think it applies to any discipline, be honest. But like that honesty probably lies on the fact that you've done your napkin math and you knew where this will scale, where how this can go, right? How did you go about doing that pre-launch, right? Before having any client? Is that the company of your friends that helped you to kind of like figure out the economics and sort of the throughput and all of these rigorous questions that you ask, as problem statements on napkin math?
I think that I should almost bring up the Internet Archive version of it. The first version of Turbopuffer, I had not thought about the business at all. I didn't have any launch playbook. I had run, of course, all the economics of what it would cost me to operate and spend a decent amount of time on the pricing because that felt like an important thing to spend time on at the time. But there was really not much more than that. Of course, the Readwise team was very interested, but at the time I could barely do I could just do around 10 million vectors, which is not enough for their use case. I can screen share the website with you right here of what it looked like at the time. And then we can get for the listening audience, we can get your reaction. But it was very simple. I wouldn't put any sophistication in. It was honestly I was exhausted. I've been working on this like completely alone, not telling anyone about it, no interested customers for like 4 months, extremely focused, like every single day. And I couldn't like if you ask my
Wow.
wife, she would say I was very distracted. And she's just like, why are you working so hard on this? Like, it's like there's no one on your team. You don't have any customer lined up. And I'm just like, someone has to do this. And I just launched it and I launched it. I mean, now I feel it's embarrassing what we did launch. It just couldn't do that much. It was pretty slow.
Yeah.
I spent a bunch of time actually trying to make it work in WASM and on the edge, but it was too hard to make it fast. And a bunch of other false starts like that on different types of ANN indexing structures. We could talk about that as well and what we settled on. But there was no real sophistication in the go-to-market. It was really just here it is, here's the
Yeah.
napkin math, here's what it does.
But
Let's
I
see how the world takes it.
but I think when you sit on a well, you didn't sit on it yet, but you had a cool like technology idea in mind, right? You knew it may play out, but also, of course, it required a lot of hard work, like you said. But after that, after you see it fly, like on some small scale or whatever scale, I think that brings you like that excitement to bring it to the world, right? So yeah, I see you're sharing the screen of the web archive page.
Yeah, that's it. Very simple.
Yeah,
Yeah.
oh, that's awesome. Uh, but yeah, that's actually a good segue to. You probably know I've been at the emergence of the field of vector database field. I've been I think I was the first probably to write just a simple blog post with like, these crumb snippets of what each vector database did and how they stand out and so on. Turbopuffer wasn't there because Turbopuffer was still in your mind, I think. But the segue here is I don't have it covered in that blog post, but in your mind, why were you not happy with the vector database like at large? Did you try all of them? Did you try some of them? Why did you think that a new vector database deserves to exist?
Yeah, I think it really just came back to the Readwise example, right? There's they look like great products. I really like the API of many of them. They had lots of features that it would take me a long time to build that even features that we don't have today, although we have a lot of features today compared to when we launched. It came out of the cost piece that it felt that there was a lot of latent demand built up in the market of people who wanted to use these things, but it just didn't make sense with the economics. It's very difficult to earn a return on search. I mean, I remember the search clusters at Shopify were very expensive, but e-commerce is a lot about search. So it was okay, right? But for a lot of companies, search is an important feature, but is not the feature, right? And so the per user economics just have to make sense. It's not that everyone just wants it in the cheapest possible way. It's that if you invest in infrastructure, you have to get a return on that investment. And it felt that I knew that at Readwise, they could get a return on that investment, but it wasn't on 30 grand a month. It was maybe closer to 3 grand or 5 grand a month that they would
Mhm.
feel that they could earn a return on that feature in terms of conversion, engagement, and whatever. So it was really about the storage architecture. And I think that when I think about databases now, this was not as coherent to me at the time. At the time, I was driven by the napkin math, not the market, nothing else. It was based on one qualitative experience and a napkin math. There was nothing else in it. I can speak about it in a more sophisticated way now, being, having learned a lot about go-to-market since. But that's really all it was at the time. It was an insight on those two things. The best ideas, right, are um, simultaneous inventions, right? Someone else would have done it 6 months later. Probably other people were doing it at the time that launched later, right? We were the first to launch with this particular architecture, but it was out there for the grabbing, right? The idea
Yeah.
was in the air. Like S3 had the APIs now finally. So the way that I think about this to really boil this down is that if you want to create a generational database company, I think you need two things. You need a new workload. The new workload here is that we have almost every company on earth sits on their treasure trove of data and they want to connect that to LLMs, especially all the unstructured data that it's always been very difficult to do. We did this for structured data in the 2010s. The new workload was that we wanted to do analytics on billions, tens of billions, trillions of rows of structured data. But now with LLMs, we're entering into that with the unstructured data. That's the first thing. We need a new workload because that's when people go out shopping for a new database. The second thing that you need is a new storage architecture. If you don't have a new storage architecture that is fundamentally a better trade-off for the particular workload, then there's no reason why tacking on a secondary index to your relational database, to your OLAP, to your existing search engine, they would eat it. I would have made that decision in the shoes at Shopify, right? It's like, well, this database like has a really good vector index,
Mhm.
but it doesn't bring anything new in terms of the storage architecture. So we're just going to invest in the MySQL extension, right? Which is what we're in Shopify, or the Lucene workload, right?
Mhm.
These are great databases. They've stood the test of time. And when you're on call, you become very conservative in what you adopt for new workloads. But you cannot ignore a new storage architecture that is an order of magnitude cheaper than the previous one. When you store a gigabyte of data in a traditional storage engine, you have to replicate that to 3 disks, maybe two if you have a little bit of, if you have more risk tolerance, but likely three. A gigabyte of disk from the cloud vendors costs about 10 cents. You run it at 50% utilization. Otherwise, it's too scary to be on call. 20 cents per gigabyte. Times three for all the replicas, 60 cents per gigabyte. Object storage is 2 cents per gigabyte,
Wow.
right?
Yeah.
So it's 30 times cheaper
Yeah.
if it's all cold. Now, by the time you have some of it in SSD, and you have it in memory, then the blended cost ends up being different, but it tracks the actual value to the customer. Even if you have all of that in disk, well, you only need one copy, right? And that
Hmm.
disk, you can run at 100% utilization, meaning the blended cost is now 12 cents per gigabyte, right? So the 10 cents, 100% utilization plus the 2 cents per gigabyte for object storage. So now you have the ingredients of a new actual database. You have a new workload, right? Means that people are out there trying to look for ways to connect their data to LLMs. And then you have the second ingredient, which is a new storage architecture that allows them to do it an order of magnitude easier and
Yeah.
cheaper than what they can do on their existing architectures. And this matters because vectors are so big, right?
Yeah.
A kilobyte of text easily turns into tens of kilobytes of vector data.
Yeah, yeah, it's absolutely true. Um, one other thing that I keep hearing or kept hearing about, whether or not to introduce a vector search in the mix for some really heavy workloads, is that it will bring certain latency on top that we cannot tolerate, right? For example, if you run a hybrid search like you guys have implemented as well, one of these will be slowest, and therefore you will have to wait for that slowest component. And so if it adds, I don't know, a few hundred milliseconds on top of your original, retrieval mechanism, then it's going to be an offline. What's your take on that? Have you thought, obviously you have thought about that. What's the edge that Turbopuffer brings in this space over maybe pure databases?
Yeah, I think we see two types of ways that people adopt vector databases or Turbopuffer. We don't consider Turbopuffer a pure play vector database. We consider it a search engine. We actually consider it a full database because there's a full generic LSM underneath all of that. And we consider that the actual asset of Turbopuffer is an LSM that's object storage native and doesn't rely on any state. We just think that the vector index and the search engine index is what the market needed the most. So let's speak about latency. There's no real fundamental latency trade-off with this architecture. The only thing is that once in a while you will hit that cold query, but the entire database is optimized around minimizing the amount of round trips that you do to S3. S3, you can max out a network card, right? So you can get on a GCP or AWS box, you can get 50 to 100 gigabytes per second of network bandwidth, gigabits per second of network bandwidth. So this is similar to this bandwidth. The latency is actually even better in the clouds often than disks, even with SSDs, even with NVMe SSDs. So the network is phenomenal. You can drive, say you can drive all of that data. You can drive gigabytes of data per second in a single round trip. So you can get great throughput, but the latency is high. The P90 might be around 200 milliseconds to S3 for every round trip, somewhat regardless of how much data that you transfer, assuming you're saturating the box. We've designed almost everything in Turbopuffer around minimizing the number of round trips to 3 to 4. That doesn't just help for S3. It also helps for modern disk, where it's the same thing. You can drive enormous amounts of bandwidth, but the round trip time is long, right? It's like hundreds of microseconds versus hundreds of milliseconds, but still substantial compared to DRAM. So the latency trade-off is not a fundamental trade-off with this architecture. By the time that it makes it into the memory cache, it's just as fast as everyone else. We have found that people don't care if it's like a millisecond or 5 milliseconds. As long as it's reliably less than around 50 milliseconds, they're good, right? And I think that a lot of the traditional storage architectures, especially because of the sharding structure with multiple nodes, you're already in a worse position than going to two systems. Where if you write a query on some of the traditional search engine, generally you touch 5, 10, maybe more nodes,
Yeah.
depending on this, because the shard size is very, very small. We can go into more depth on that. So you already have this problem. What we see is that there's two types of ways that people adopt it. So the first one is you have an existing lexical search engine. You are having a hard time running it because of this traditional, like very stateful architecture, and they're reputed for just being difficult to run. And you're like already a little bit at your threshold for the amount of money that you're spending on this cluster. And if you put the vector data in, it's often 10 to 20 times larger than the text data. It is just it's a project that stops in its tracks, similar to the Readwise case that I mentioned before. So for those players, we often see that they have something that's really well tuned for the lexical, and they adopt a vector store, and then they do two queries in parallel. The vector store should not be slower than the lexical, right? So these are just two futures that you merge together in userland. And in general, we see that our customers are actually quite happy to move some of the ranking and the final like second stage ranking out of the search engine and into a search.py instead of a big search.json, which can be very difficult to maintain. Many of these companies express a lot of desire to move more and more of their lexical work also onto Turbopuffer, and we have a full text search engine. We don't have every feature of Lucene yet, but we're working very, very actively on bringing this up. What we also see is that a lot of our customers don't need all of the features of Lucene anymore because the vectors are so good that a lot of the PhD level efforts we did before to turn strings into things is
Mhm.
not as much of an issue anymore. And really, what we use strings for more is that when you search for DM, you get Dimitri, right? Like
Yeah.
for a prefix match, whereas an embedding model might think that that's a direct message. Those kinds of things are important, and we still need string matching for that. Lots of applications need it, but there's a lot of things that we do in Lucene with synonyms, with stemming, with all these kinds of things that the models are frankly just a lot better at. So we find that this is an adoption curve that is there. A lot of the newer companies just start with embedding models and simple full text search and they get it up and running on Turbopuffer and they like that they just pay for what they need. They don't think about it and they could pump a petabyte of data in if they wanted and it would be extremely competitive on pricing and they don't have to think about it.
Oh, that's awesome. That's awesome. Actually, I forgot to mention, I forgot to ask you, which language did you choose to implement Turbopuffer on?
Yeah, well, it was just me at the time, but I chose Rust,
Hmm.
and I think I'd spent the majority of my career writing Ruby at Shopify,
Yeah.
and then a lot of Go as well for some of the infrastructure components, and then mainly debugging C, which all the databases that we were using were doing and reading C. Um, I really like Go, and I like Go alongside Ruby at Shopify because Go was one of those things as when leading teams, I didn't have to worry about whether someone knew Go or not because the adoption to learn it is 2 weeks. Um, the adoption to learn Rust and being proficient in it is months, right? And
Hmm.
someone that's written Rust for 2 years is a lot more productive than someone who's written it for 2 months in the language. And that's just not the case for Go. Like someone who's spent 2 years in it is just not that much more productive than someone. And I think that's an amazing feature of the language. But from my own point of view and from the napkin math point of view, I was always so hungry, having been inside of runtimes in the Ruby MRI runtime and inside of the Go runtime. I was just hungry to just get directly connected to the metal of the machine. And
Yeah.
so, and for a database in particular, that was very important, right? We need to vectorize everything. We need full control over that. And I think that full control, as remarkable now as Go is, which I think it would have been okay. That raw access to the machine is needed for writing something like Turbopuffer.
Yeah, yeah, for sure. I still remember coding the times when I was learning and coded industrially in C and C++. Like you really needed to be very, very careful, but in return, you can get a lot of like performance gains, and some of your ideas really fly. But yeah, today, I guess I'm coding more in Python, or should I even say that I code in Python when I use cursor more and more, uh, which is, by the way, scary. That feeling when some other entity writes code and you are just reading it, right? It's a little bit scary, and I'm still grappling with it. But the amount of productivity that I get is enormous, and it's like I can ship daily like features and just see them being used. That's amazing. Um,
I think
yeah.
what I love about it is that um, I still love to sit there and write the artisanal code by hand. Maybe at some point we will mark Turbopuffer as an artisanally written database because we don't use a ton of AI for the very key parts. Because I mean we're at the edge of what the LLMs could know. But I think that for me, in a position where I'm in and out of meetings all day these days,
Yeah.
But I can actually get a lot done in a 30-minute window when I have somebody that's prompting and writing the tests, right? And
Yeah.
you find it off at the beginning of the meeting, you check in the like, 15, 30 minutes you have in between blocks. And this allows me to actually contribute a lot more code than I was otherwise going to be able to. Not into the core engine, I don't get led into a lot of that anymore because I don't have the time and focus that it takes to fully think something through there.
Yeah.
But for the website, the API, tangential features, all of that, it's just been wonderful.
Yeah. Wow. That's amazing. I also wanted to go a bit on a tangent. Like you essentially you've been, you could say, mathematician, engineer, but you took a leap towards becoming a CEO, right? And I think you now, as you said, you go to meetings, you do lots of, probably sales and product and all of that stuff. Was it a natural transition for you? Like what have you learned in this journey, and what maybe do you miss from your previous career when you were like, hands on and sit down and write a bunch of code?
I think I have a couple of angles to answer the question, not necessarily a direct answer. I think one angle is that fundamentally I'm like a growth junkie for better or worse. And I think that entrepreneurship is the ultimate path for a growth junkie. It was never really something that I assumed that I was going to do. I've never before, even when I was working on the project, it was never about becoming a founder. It was just about creating the database, right? And at some point, becoming the founder of the company becomes a means to an end of creating the database and getting it into the hands of our users and making sure they have a great time. That's always that's what drove me, right? Was the Readwise should have this, right? Our customers should have this. They should have a great experience. And that's always what's driven me. And to me, the founder and all of the other things have been a mean towards an end there. I think that one of the things that is maybe both a controversial but also feels like a true statement is that at some point I feel a bit numb to what work that I enjoy and what I don't enjoy anymore. Because what I enjoy the most is making this company successful and making the database successful for our customers. That's what I care the most about. And I honestly, I love sales. I love marketing. I love the engineering. I love hiring people for the team. I love all of these things, but it's not a simplistic answer to, oh, I've been coding my whole life. I think it's more that that is my idle activity. If there is a 1 to 2 hour and there's nothing urgent on, then I'm gonna go spend some time in the code base. It's like, oh,
Yeah.
how did Nathan implement this new query planner heuristic? That is the natural. That's where my idle activity. And I always like to also when interviewing people try to understand, especially if they're in a more hybrid role, what's your idle activity? What's the thing that you do when
Yeah.
you have 1 to 2 hours and nothing
Yeah.
else comes up? Do you gravitate towards the code? Do you start looking at? Do you start writing an article? Do you start playing with the product? What is that idle
Yeah.
activity? And it is code for me. That's what everything is grounded in. And I think it has a deep influence on how I can lead the company. Um, but I don't think it's been. I think I often think about something that Taleb said, the author of Anti-Fragile and a bunch of other books, is that the best authors of books are not the ones that sit down and read a bunch of papers, then write a page, then read another paper, write a page. The best books are written by people who just, go to the cabin, sit down, write 500 pages and hit publish. Of course, that's not what actually happens, but if you read the Taleb books, it's probably pretty close to what actually happened. And he just has the citations in his head. And I think about that often when building this company, that it has felt like I've worked for this my whole life without knowing for it. And I feel every morning that I wake up that this is exactly what it has led up to. So it's very natural, even if it wasn't goal onto itself, that it makes sense with the experience I've had to do exactly this. And I tremendously enjoy it. But it's not a simplistic answer to, do I miss coding?
No,
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 I
no.
want to make this company incredibly
Yeah.
successful. But sometimes I will do it as a recreational activity.
Yeah, I mean, definitely, like when I look at you, like on Twitter, for example, you come across as a very technical person, and you are for sure, right? Even though in order to grow your business, you need to do a lot of other activities. But at the same time, I mean, yeah, I don't mean to ask it in a way that, hey, you regret now that you do sales, you regret not doing more coding, which is not true. You still do that. And I think that all of the engineers will become better engineers if they learn the mastery of actually presenting what they do, right? And then they will not need a middle layer or someone else who will go and talk to that product manager or whoever else needs to talk to, right? So they can actually represent themselves. But I also love how you put it really eloquently that what is your idle activity, right? What's your affinity, what you gravitate to? And I actually can, it resonates a lot with me because my idle activity, when I'm really nervous that I do nothing, especially on vacations, I start coding. I just go and just, okay, let's just hypothesize about something. But let's dial back for the into the architecture. Like when I look at the architecture page of Turbopuffer, it's very simple. It's like client connecting over, TCP to a database instance, and it has just two components there: memory or SSD cache, and the object storage. Tell me a bit more. So I think our listeners and I mostly know what object storage is, but tell me a bit more about that memory component. Like what algorithm design went into that, maybe trade-offs, and how frequently you need to do the round trips to the object storage versus when you actually don't do that.
Yeah, I think it would be easiest to do this by speaking about the lifetime of a request as the cache warms. So we will actually start with the write path. And when you do a write into Turbopuffer, it's as simple as you can imagine it. I mean, at this point, we've optimized parts of it that it's not this simple, but this is the best way to explain it. When you do a write to Turbopuffer, that write basically goes into a file in a directory called the write ahead log. So when you write to a namespace, you can imagine that on S3, it's like slash namespace slash, write ahead log. The write ahead log is basically just a sequence of all the writes in order, the raw writes. So you do your write, and it might be, okay, I'm inserting a document with text Dimitri and one with text Simon. And those are the two documents. You can, in the simplest way, you can imagine that this file is called 0.json, and the next one is called 1.json, 3.json. That's a database, right? That's just the write ahead log. And if you want to satisfy a query, you just scan through all the JSON documents and you satisfy the query. That's actually a respectable database. It's not even that far from the first version of Turbopuffer, but of course, you have to index that data as well. So basically, as you can imagine, once many megabytes of data come in, asynchronously, an indexing node will pick it up and put it into the inverted index for full text search, put it into an ANN index for vector search, and put it into a attribute or filtering index for other attributes. And there will be other indexing types in the future. When that happens, it will put it into slash namespace slash index and just start putting files in there, right? And then the query layer can then consult those files, right? Instead of scanning through every single document to find Dimitri, it can just plop in and look at Dimitri in the inverted index, find the document, and return it. That's how a write works. When a write happens, it will go through one of the query nodes, and the write will be also written into the cache, right? So both the memory cache and the disk cache. And when you do a query, you will go to that same query node, right? There's a consistent hashing. So if there's three, it's sort of like the same namespace will end up on node one all the time if it hashes to that node. When you do a query, it will first check the caches. If you just did the write, well, it's already there because we just wrote all the writes into the cache to have this, the write through cache, and we will satisfy the query mainly from the cache. If for whatever reason this namespace is not, maybe you did the write a month ago and so it's fallen out of cache and you do the read, well, then we'll read through cache by going directly to object storage with as few round trips as possible to get the data to satisfy the query, both from the index and from the wall. We'll do range reads directly on S3, right? The old like HTTP range header to get exactly the bytes we need to satisfy the query, and then start hydrating the cache on the query node so that subsequent queries get faster and faster. And we can do that at gigabytes per second. We can hydrate the cache, even for very, very, very large namespaces. So that's the general architecture of Turbopuffer. On a completely cold query, it takes hundreds of milliseconds. And on a warm query, it can take as little as 10 milliseconds to satisfy the query. The last detail I'll point out, and then we can go into a particular aspect of this, is that Turbopuffer has chosen to do consistent reads by default. This is an unusual choice for search engines. Lucene doesn't do this unless you turn it on explicitly. I think they've done more work now for real-time indexing, which to me is the gold standard, which is why I keep referring back to it. It's a phenomenal piece of software. And Turbopuffer has consistent reads by default, meaning that if you do a write and then you read immediately afterwards, that write will be visible. And in order to satisfy that, we can't just rely on the cache on that node being out of date. That node could have died. It could have, the hash
Yeah.
string could have moved because we scaled up. So every single um, query, we go to object storage and see what is the latest entry in the wall and do we have that entry, right? Is it at 3.json or is that 5.json and do I have that? So we have a little pointer file that we can look at, we can download and look at, right? And that round trip is basically our P50. Like our spans are basically, often like 1 to 2 milliseconds of actual search. And then on GCS, about, depending on the region, 12 to 16 milliseconds, waiting for that consistency check. On S3, the small object latency is a little bit better, so it's 8 milliseconds. But you can turn this off and you will still get up to, you can get eventual consistency that's very normal for these databases, like could be up to 1 minute out of date. And then you can see often less than a millisecond or a millisecond latency to Turbopuffer by turning off that check. But we find that this is a very safe default. And I think that databases should ship with very safe and unsurprising defaults.
Yeah, for sure, for sure. So in that cache, but you also have the let's focus only on the vector search part for now. You also have the ANN index. Is that also stored on S3? And then do you also keep kind of like a replica of it in memory to for quick access? And how do you sort of, if true, how do you sort of synchronize the two?
Both the write ahead log and the index are everything is stored on S3. If you killed all of the compute nodes of Turbopuffer in all of our clusters, we would not lose any data. There is no data on the compute nodes that matter. It's only transient caching. But we cache everything. Yeah, if you're accessing the index, we'll cache the index. If you're just accessing the write ahead log files because it's so small or there's parts of the data that hasn't been indexed, then that's also on S3 and goes into the same cache with everything else, right? Prioritized by the workloads to try to get the best performance possible.
Yeah, it's quite smart. So effectively, like I remember like at some previous companies when I was running Apache Solar, one of the problems was always that all of these shards are super cold because they're never used, right? We still pay for them. But then when the query hits, you incur so much latency that it's super painful. And so I was always coming up with these ideas. What if I run some, post-indexing warm-up script that will go and shoot a bunch of queries to all of the shards just to keep them, up and running and warm, or just cat all the indices on Linux into memory. We've done that too. That was like 10 years ago or so. That was very strange feeling. Like, why do I need to mess with that level of detail? It never actually paid off. I think what pays off is a most smart way to organize your index and how you read data backwards. Like, essentially, when your users really only need fresh data first, like on Twitter, for example, everyone is really after the recent tweets and not some archive. And that was a very similar case for us. But it's very interesting. Like you go into so much detail there to like make the database effectively like a living organism, adjusting to the usage. But you also have multi-tenancy, right? So meaning that the same turbopuffer deployed across the data centers is going to be used by multiple companies at the same time, unless they demand an isolation. How do you think about that when they use the same, effectively the same instance, compute and index?
I'd love to go into the solar example for just 1 second before we go into multi-tenancy. Um, how slow were those queries? Because when you say cold, you mean that it's not in memory. When I say cold, I mean that it's on S3. What kind of latency were you seeing that you
It
had to do these
it
workarounds?
was very slow. First of all, the it has to do also with the domain specificity. The queries were Boolean and very long, and so they would take some times. Just the query itself would take a minute to execute on our like original index design, and that was like just super crazy, right? But it was also very accurate because it was like sentence level search. And then I had to design a new system, new architecture where we could retain the accuracy of that engine, but not have to spend so much money on indexing individual sentences. So we indexed one complete document, right? So I had to change the algorithm slightly, and so it went to sub-second. It was still, I think it's still slow, right? But it was much faster, and users started like we could scale the company effectively after that, right?
That's
With 1 minute, and 75% of infrastructure costs were like, shaven off. So, but that was part of the Lucene, munging with the algorithm and changing how it scans the document. It had nothing to do with the level that you go into, with Turbopuffer, like effectively controlling the whole process there.
got it. Yeah, I think the point there is that I think that we do see that some customers are concerned with with disk cache because they've gotten bitten by basically the way that I would think about it is in some of the traditional engines, the way that they do I/O, if something is on disk, it feels like it's bad. Like if it's on disk, it's slow and it really has to be in memory. And so you sort of have, the puffer fish is either, the puffer fish is sort of because when it's fully inflated, it's in DRAM, right? When it's in deflated, it's in S3. Well, it only had two settings, right? Either it's in disk, which is quite slow. And frankly, in some of the traditional storage engine, I've seen the latency on disk being similar to our latency on S3.
Yeah.
And so then you have to load it into DRAM. And what a lot of these traditional databases, like they have to do a full copy into DRAM. They can't just like zero copy off of disk. And then the disks are also quite slow, these old network disks, right? The NVMe disks are so fast, right? They can drive bandwidth that's within a very low multiple of DRAM, right? Tens of gigabytes per second. But their cost is almost then two orders of magnitude lower. So this completely changes the economics, but you can't take advantage of these very easily. You can't just put some software on it and just it's going to be like 10 times faster than an original disk, even if it's fundamentally capable of it. Because what we found, for example, is that we had to remove the Linux page cache because the Linux page cache cannot keep up with these disks. So you have to do direct IO. But when you do direct IO, you don't get coalescing, you don't get all these other things. So now you have to write your own IO driver, right? And so databases have not been built to take advantage of it because they're also like they're not built to try to do an IO depth, like basically so many outstanding IO requests they can drive there's so much throughput. So there's just a lot of barriers of entry there. So what we find is that when again, speaking in generic terms here of like, millions of vectors queried at once, when something is in disk, it's maybe high tens of milliseconds, mid, 50, 70 milliseconds when it's fully on disk, maybe lower, depending on the query, the machinality, whatever. And when it's in memory, it's closer to 10 to 20 milliseconds, right? So it's like, this is not bad. Like the user is barely going to notice it. But of course, you're going to get more throughput that way. And then when it's on S3, it's maybe more like 5 to 600 milliseconds, which sort of a user would notice. But a lot of our customers, like Notion, for example, when you open the Q&A dialogue and these different dialogues that will query Turbopuffer, they will send a request to tell Turbopuffer, hey, can you start warming up the cache here in a way that makes sense? And by cache, we just mean putting it into disk and starting with sort of the upper layers of the ANN index and other things to reduce the time as much as possible. So there's a lot of things that can be done here that are very, very simple. That means that there's barely a trade-off.
Yeah. Yeah.
But let's go back into multi-tenancy, unless you had a follow-up
Yes,
on
let's
this
do
one.
that. Yeah, let's do that. Like, how do you view
So,
multi-tenancy part?
so Turbopuffer can run in three different ways. It can run, yeah, in multi-tenancy clusters. That's what that's what Cursor does. That's what Linear does, and many of our customers. So in multi-tenancy, you share the compute. We can do this so cheaply, right? Because we can share the caching, we can share all of this infrastructure. It's very easy for us to run this way. So that's the default mode. The cache is, of course, segregated off in different ways, but is also like shared in ways where if you have a big burst of traffic, right, you get more of the cache than others. So that's what we So it's a very great way of running multi-tenancy. The other thing we do for multi-tenancy to keep it very secure is that because all the data at rest is in the bucket, you can pass an encryption key to Turbopuffer that we don't have access to unless it's audit logged on your side, where we can encrypt and decrypt the object, which is logically and from a security standpoint equivalent to you having all the data in your bucket.
Mhm.
So this is a very nice primitive that, for example, Linear takes advantage of because they have full control over their data. They can see when Turbopuffer is accessing it. They can shut it down at any point in time. And they can even pass that on to any other customers where Turbopuffer can encrypt data for Linear's customers on behalf of the customer with the customer's key. This is like really,
That's
really, I think, groundbreaking and underrated in this architecture. You can, of course, do single tenancy with Turbopuffer as well, where the compute is only for you, or you can do BYOC, where we run Turbopuffer inside of your cloud in a way that's like very compliant. We can never see customer data, but we find that the multi-tenancy with the encryption, which can be done per namespace, satisfies the security requirements of even some of the biggest companies in the world.
Yeah, that sounds awesome. I also wanted to pick one topic which usually used to, I don't know if anymore, I don't see that as much, pick up a lot of flame discussions. What is your recall at n? And when I go to the docs of Turbopuffer, it says recall at n is 100%. Recall at 10, excuse me, for vector search part. So does that
Not
mean that?
100%. We said 90 to 100, right?
No, I think it says, wait. I'll need to, what was the page where you do that? Oh, here, the limits, I guess.
Oh, I see. Observed in production. Yeah, it should say up to 100%. That's a bug in the docs that I shipped last night. I'm gonna fix that after this.
Awesome. Yeah.
But what it says in the limits is 90 to 100%. But let's talk about recall. I'd
Yeah.
love to get into recall. So I think recall is incredibly important. It's the equivalent of your database. You have to trust your database to do it in the same way that you have to trust your database to F-sync. And you have to trust your database that when we say that, hey, we don't return a success to you unless it's committed to S3, you have to trust that. Recall is similar, right? If you are working on search and you're working on connecting data to LLMs, then you don't want to worry in your evals on whether your vector database is giving you low recall. It's actually a very sophisticated problem to evaluate whether this is the cause. So you have to trust your vendor. This is an underrated problem. And I love that you're asking about it, and very few people ask about it unless they're quite sophisticated. So let's go into a long answer here for your audience because I think this is paramount. Most databases that have a vector index are trained on, or not trained on, but they're benchmarked against for these different ANN open source projects. So there's SIFT and others. Problem with these data sets is that they do not represent what we see in the real world. A lot of them are very low dimensionality. Like when we do benchmarking on a billion that we're working on right now, the biggest data sets we can find are like 64 dimensions. This is not what people are doing in production. They're doing at least 512. Often, generally, I'd say the average is around 768 dimensions. These are not representative data sets. And the distributions in the academic benchmarks are also completely different from what we see in real data sets, right? In real data sets, we see millions of copies of duplicates, right? We see filtering, all these chaotic environments that do not present themselves in the academic benchmarks. So if you're using a vector index that's only been tested on academic benchmarks, it's I mean, it's like the LLMs, right? It's like you don't really trust it just based on the scoring. It's sort of it's
Yeah,
all the vibes, right? It's all the
exactly.
qualitative thing, right?
That it will
Outside of the
use, that
benchmark
will
because
work for
everyone's
your,
training on them.
that it will work for your domain, right? Like the LLM
That's
will.
right.
Yeah.
Like early on, very, very early on in Turbopuffer's history, in the first month, I was mainly iterating against the SIFT data set, right? Just like 128 dimensional data set. I didn't know anything about ANN at the time. So it's like, okay, this is pretty good. We can tune some heuristics on this and then I can go wider, but I have the feedback loop. And the observation I had at the time was that I found that so I got something that worked really well, great heuristics on SIFT. And then when I went it on the other data sets, it just completely did not work well or generalized to the other data sets. And I think that taught me an early lesson that these academic data sets are just not enough. And the only way to know what your recall is going to be is to measure it in production. This is what Turbopuffer does. for a percentage of queries. It depends on the number of queries that you do, but let's say around 1% of queries. Turbopuffer will run an exhaustive search against the ANN index on a separate worker fleet. We will then emit a metric to Datadog that is the recall number, right, for this query, right? Like, which is basically, okay, this is the top 10 that we know is accurate, and this is the, heuristic ANN index, what's the overlap? And we will average that over time. I have a graph in Datadog that shows all the different organizations that have more than 100 queries in the past hour or whatever. And then we have the recall for all of them. We have the recall at what they asked for, the recall at 10, the P10 recall, the P90 recall. And we tried our best to make sure that this is green at all times. And we consider green anything above 90% is generally quite good. 90% is quite good for some queries, but for simpler queries, often it's closer to 100%. Many of our customers have 99.5% recall. So this is the only way that we know to do this. And it's funny you asked this question today, because last night I was hacking on putting this into the dashboard. So literally putting the recall that we observe from this monitoring system into the dashboard of the user, because we think it's that important. And it's very difficult to get right. We have spent thousands of engineering hours to make sure that the recall is high. Now, recall on academic benchmarks, easy. Recall on raw ANN search is, especially on academic benchmarks, very easy. Raw recall on production data sets, I'd say medium to medium hard. High recall on ANN queries with filters, with mixed selectivity and incremental indexing, absolute hard mode. This is what you just slap a secondary vector index onto an existing database. This is what they can't do. They can't sustain like 1,000 writes per second with high recall in the face of very difficult filter queries. So let's talk about filtered recall for a second. There is barely any academic data sets on this, yet it's all the production workloads. What a filtered ANN index means is that, let's say that, for example, you have an e-commerce store and you're searching for I don't know, yellow, right?
Mm-hmm.
And you want to only get things that ship to Canada. That cuts the clusters in different weird ways and might end up with a selectivity of 50%. And so if you just visit the closest whatever vectors with some
Yeah.
heuristic you have, you're not going to get the true ANN, because you actually have to search maybe twice as many, maybe 3 times as many vectors to get the right recall. The query planner, the thing in the database that decides where to go on disk and figure out the data and aggregate it all together and return it to the user, needs to be aware of the selectivity of the filter and plan that into the ANN index. Again, if a database is not really serious about their vector offering, they're not doing this. They're not measuring it in production. They're not willing to show their users, and they don't have a full infrastructure in place to measure the recall. So I'd say we take this extremely seriously, and we don't want our users to have to guess this. And it's sometimes a thankless job, because many evals that we see against some of the other vector indexes have very low recall. And how are users supposed to know? Because running these tests is extremely difficult.
It is, and it's like, it's as you said, like you need to trust there, right? Trust your vendor, and it's basically like like in some documentation pages you say the floor, or like the bottom line, right? Like beneath which it just doesn't make sense, right? If the quality isn't there, then why are you even running this? Yeah, like it's a
Yeah.
difference between, finding that product with those constraints when it exists, and actually not finding it, right? Therefore, not buying it, and so on and so on and so forth.
That's right. And
It's
I
crucial.
think
Yeah.
you can never guarantee a recall. You can observe what you are trying to make it be on every data set, but if you send a billion completely random vectors with 3,000 dimensions and try to query them in Turbopuffer with query vectors, and there is no natural clustering because they're random vectors, you're not going to get 100% recall when you send that with a 10% selectivity filters. That just like completely breaks every heuristic that's made, right? But all data in production, real data that people want to search, has some natural clustering to it. So that's not a real benchmark that you can evaluate recall on, right? And so we always take this seriously. And in POCs and with the monitoring we do, we're looking at these numbers all the time. But there are like absolute edge cases that can be very, very difficult. And what you have to do too as a database vendor is like it's a tug of war between we're going to look at more data to try to get high recall, and we're going to try to improve the clustering of the data so that we have to search less data. And so you're always trying to improve the clustering, and you're always trying to improve the performance of the database so we can look at more data to get high recall.
Yeah, for sure. And now that you mentioned about filtered, challenges, big NN, I don't know if you're aware of those. There is an
Yeah,
ANN benchmarks, right? But there is also a big NN benchmarks that I happen to have pleasure to participate in. They have one of the data sets, one of the tasks they have is the filtered search. I have not participated in that one, but again, as you said, it's kind of like academic, but some of the data sets are quite large, like billion points. Dimensions are not that huge. It's like
that's the thing.
capping
There are
at
100,
250,
there
256. Yeah, it's not like
Yeah, there are hundreds to 200
thousands.
dimensions. These are not real data sets. No, they're real data sets, but they are
Not
real data sets
representative.
from the past generation of vectors, right? The
Yeah.
pre current modern embedding era, right? Which are just score so much higher than these. So we just don't see people use these.
Yeah, yeah, exactly. It's still fun to participate in this benchmark, by the way, because the data is there, and the some of the guarantees that you need to hit are really high. Like tens of thousands of queries per second. So if you can create a toy index that works, it's just a proud moment, I guess. Um,
That's right. But I would say that people don't care about these like
yeah,
people care about the benchmarks like they're fun competitions, but I think it can ruin your company if all you're trying to do is maximize these benchmarks, because how many companies in the world are trying to do 10,000 qps on a billion vectors,
exactly,
right? Not that
exactly.
many, but there's a
Yep.
lot of companies that have a billion vectors lying around that they want to search, and they just don't want the pricing to be offensive, right? Where Turbopuffer can do this depending on the dimensionality for like $1,000 a month. That's what people really seem to care about.
Yeah, for sure. Maybe if I ask you like a spicy question, if I may, why do you think some of the vector database players like indulge themselves into that game of showing the benchmark and telling we are the best, and then someone else cuts them over and says no, you made a mistake in the benchmark? Why do you think this is happening, like publicly, if you are comfortable talking about this?
Yeah, we don't publish benchmarks against anyone else. And in fact, it's usually against the terms of service to do that for almost every vendor, including the big vendors like the hyperscalers. Probably shouldn't be It probably should be prohibited for the hyperscalers for like anti-competitive reasons, but anyway, for the peers, I think it's like a low blow because everyone can sort of p-hack their way to something where they go better, and it becomes like mud throwing, and it's very distracting activity. We benchmark ourselves in ways that we find that our customers are actually using the database. So we're not doing it at 10,000 QPS because it's just not what we see to a single namespace. So we benchmark against ourselves. We benchmark against first principles, and we're always considering what is the gap between what Turbopuffer does and first principles.
Yeah,
There's That's what I've learned. That's why I do Napkin math, is because the fundamental thing you should be benchmarking against are first principles. There's a gap between what the DRAM or disk bandwidth is multiplied by how much of it you need, and your database is not doing that. Well, then you either have a gap in your understanding, or you've found room for improvement. That's what matters. And of course, it also matters what other people are doing, but what matters the most is what your customers are trying to do, and they'll pull
yeah,
you in that direction. So we think that this easily becomes one of these metrics where, if you give people a metric, they'll optimize for it.
yeah,
And benchmarks of how many QPS you can do at some number recall, it's just not what people care about. They care about it working. They care about enormous write throughput. They care about costs. They care about other things necessarily that are much harder to put in such a benchmark. I think benchmarks are important. Like, we need to give people a sense of what they should expect, and they should hold us true to that. And what I would love to have is like more observability in the Turbopuffer product of like, what kind of like performance are you seeing? We're working on, explaining or exposing query plans from Turbopuffer, right? So you can see
yeah,
what's causing the indexing, what's causing the query latency to be what it is.
hmm,
So yeah, I don't think the mud throwing is great. I think that at some point someone's going to publish a benchmark with Turbopuffer, against something else, and then we'll have to deal with that as it comes, right?
Hmm. Yeah.
But it's certainly not an activity that we plan to engage in.
Yeah, I love your answer because it also resonates with me. Like in a different dimension, I found myself in a situation when, at some point in the past, when we've been copycatted. Can we say it that way? So there was a company that really literally copied the whole interface and like how the product looks, and we felt threatened. But what they couldn't copy is essentially the internal IP, right? All the algorithms, everything where we've spent hard working time on, they couldn't copy that, and effectively that doesn't fly by itself, right? So basically what I'm trying to say is that, even though it felt threatening, still thinking about what you need to solve, right? Barring the laws of physics, you really need to focus just on that. And if you solve that, you become the leader of the market. And that's what happened to the company, actually. The story was that it actually acquired this copycat, right? And that's it. I mean, it doesn't mean that's the bad thing, bad outcome for either of them. But what I'm trying to say is that just focus on that thing that you are trying to solve, and don't try to indulge into these, games of, like you said, mud throwing and stuff. I like that. Really well said.
Yeah, I think so. We focus on customer studies. We focus on first principles. We focus on benchmarking, and we focus on what our customers are telling us that they need. And I think those are the right things to focus on for our
Yeah,
company.
for sure. And just looking at the clientele, right? The ones that you shared, just knowing those names, Cursor and Notion, that everyone is pretty much using every day. That's like a testament to what you've done. Um, I also wanted to ask you before we close. I wanted to ask you about what are the maybe technical or business or some other challenges that you see ahead of yourself, or maybe that's what already is happening and you see that it's important, especially in this space of LLMs, where LLMs can bring value. um, what is it feels like you are wildly successful as a business and as a technology, but is there something that you see is still unsolved and it is ahead of you and worth solving?
I'll go back to I spent a long time at Shopify. And so part of growing up at that company from when I was very young was being taught a bit in the school of Toby Lutke, the CEO. And something that he often said is that, you about himself is like you have to grow to keep up with the business. And that's what it is for me as well, right? I first had to grow as an engineer to put out the first version. Then I had to build an engineering team to take it much further than I ever could alone. And I think we have just an absolutely like 99th percentile engineering team now. Then I turned my focus to sales and learning that. And now I have to turn it towards marketing, towards legal, towards all these different things to build the company. We spoke a little bit about this before, but I think that one of the beliefs that we have is just in the talent density of the team. And I don't think there's a lot of I think that a lot of people talk a lot about the talent density, and I think that there is now a generation of companies that's really trying to do it. I think that the tools that we now have available to us, and especially the kind of tool that we work on every day, the floor for productivity has been raised, but the ceiling has been raised far more. And so what really matters to us is having a team of individuals that where everyone is a player, right? We see these teams assembled almost more like sports teams today, than how companies were originally built. And I think that we hold that as a strong belief in how we are building the company, but it demands a lot from everyone to work in this way. But it's very fun, and I think that the growth that embodies on everyone, including myself, is important, and I have to keep up with that. I have to keep up with the demand of how our customers and our team internally, and everything grows, and that's the biggest challenge, is just the amount of new that has to be learned, so that we can become a successful company, which is important for me, for our customers, and for everyone who's chosen to come along for the ride and join the company.
Oh, that's awesome. Yeah, this field changes so quickly. Um, it felt much slower when I was coding myself, Java, Lucene, and all that stuff. You had like Solar, Elasticsearch, that's it for like long time. And then a lot of new engines popped up, especially when vector search appeared on the scene. But now with the LLM advancements and all of that, it just feels so crazy. So yeah, it's very interesting challenge for sure, personally and business wise and team wise. And yeah, and keeping
I
balance
think
is another
the
one.
I think the pace that we see everyone running at now into successful companies is beyond anything that I've seen before. It reminds me of just the months leading up to Black Friday at Shopify, but it's all the time. And I love it. I'm addicted to that pace. And I think that we have created a team of people who seek intensity. And that's exactly what we think that we need to create the right product at a pace that makes sense for also our customers so that they are never bottlenecked on us. And that is what keeps me up at night.
Oh, that's awesome. That's awesome. That's a great cause. Um, we usually end with some sort of announcement. Anything you want to say to the audience, especially now that you said that you want to go deeper into marketing. Maybe it's your chance. Anything that you want to share or call for.
I think that we've refrained from doing any large releases and we try to just ship as rapidly as we possibly can. If I look at the changelog this month, it's I mean we launched the region in Singapore, Canada. We've added the float type. We've recently added clients for Java, Go, Ruby. One of the things that I think is really exciting is our conditional writes. And this is where Turbopuffer is not just a bunch of files on S3. It's not even just a search engine. It can do conditional writes where you can say, hey, I only want to replace this document if it's newer than the old version, right? These are real database features and things like patch, right, where you do a partial update. But we just launch and then we put it on X and we move on. So I don't have any big announcement. We went GA a couple months ago. I would have loved to have done that, but we just try to ship and announce and just get it out there as soon as possible, move on and ship the next thing.
Yeah, congratulations on GA on your original launch, but on GA, I think it's a big milestone as well. And as you said, you are probably not as sort of transactional anymore. You just keep shipping and you follow what the customers need. And but sometimes some of these things may go unnoticed unless, people follow exactly what you do. And so in that sense, I feel like there is a room or stage for saying, "Hey guys, go use it. It's GA, right? Run your
I
benchmarks."
think now that I think about it a bit more, I think one announcement might be that early on in Turbopuffer's history, we were very focused on doing many namespaces that were small, but we are getting very good at large namespaces now. And we have customers that are searching billions of vectors at once. And we have customers that want to search hundreds of billions of vectors all at once. And we are working with them on that. And this is not particularly scary anymore. We know exactly what we need to get there. So if you have use cases of that caliber, you may have passed by Turbopuffer before, but we're getting ready, and we are ready for hundreds of million and billions at once. The only limitation there is really just the size of a single machine, and then we shard over them. But I think back to the sharding we had before, you need to make every shard as large as possible to get the best economics and the best performance. And that's been one of the issues with some of the traditional storage engines.
Yeah, for sure. Hey, I really enjoyed the convo. I know we could have gone in so many topics. Like I really wanted to ask you also about ANN algorithms and stuff, but I've also I feel like we could talk more later as well, down the road as you guys are progressing. Hopefully you'll be open to that. But I've learned a ton, and it's very interesting design that you have, and the whole journey of you pushing for 4 months, uninterrupted. I hope you now regain some of the balance back to your life now that you have the team supporting you. But I've really enjoyed this conversation, Simon. Thank you so much for your time.
Thank you, Dimitri.